In this video we're going to look at multiplying and dividing algebraic fractions together. Just like when we're multiplying and dividing numerical fractions, we are going to find life a lot easier if we look at simplifying our fractions before we multiply them. So I'm just going to get stuck in and tackle this first one here. What you need to do before you multiply them is carefully study each of the terms involved on the top and see if anything on the top will cancel out with anything on the bottom. You should always try and study any numbers first before moving on to any letter terms. So I'm looking at the 2 to begin with, and I can see 2 isn't going to cancel out with the 3. However, the 6 and the 3, they have both got a common factor of 3. If I divide both of these by 3, well, 6 divided by 3 will leave me with 2, and 3 divided by 3 will leave me with 1. That's me dealt with the numbers. I now move on to the letters. I've got an a cubed on the top and an a on the bottom. So if I divide the bottom by a, that factor will be reduced to 1. And if I divide the top by a, that will be reduced to a squared. Remember, a cubed is 3a's being multiplied together. Dividing by a is going to cancel out one of them. The b's now, I've got a single b on the top and a b squared on the bottom. So if I divide both of these by b divided by itself gives me 1. B squared divided by b will give me a single b. Now I can get on with the multiplying. I've got the 2 times the 1 times the 2. So I'm multiplying using any simplified factors there. Moving on to the letters, I've got an a squared and no b's left. So that needs to be a squared. On the bottom, I've got 1 times 1 times a b. So that leaves me with a single b. Notice I've not written the 1 in front of the b. A quick check, nothing on the top cancels out with nothing on the bottom, so I have expressed as a single fraction in its simplest form. Next one, I need to take a little bit more care. I've got a division. Whenever you are dealing with a fractional division, when you're dividing by a fraction, you need to multiply by the reciprocal. So that first fraction, it will never change. What you are dividing never changes, but we multiply by the reciprocal. So x plus 2 over x plus 1. Now, whenever I've got expressions like this in a fraction, I often like to write them in brackets, so I can think about them as factors in their own right. I'm looking at the tops and bottoms, looking for anything that will cancel out. I have got an x plus 2 on the top and an x plus 2 on the bottom. So I can divide the top by x plus 2 to get 1, and the bottom by x plus 2 to also get 1. The x plus 3 and the x plus 1 don't cancel each other out because they are not the same factor. So I've got one lot of x plus 3 on the top, and I've got one lot of x plus 1 on the bottom. Again, you can write that with or without brackets. I always tend to put the brackets in. Now remember, you cannot cancel this x and x out because x is not a factor. We've got x plus 3, x is being added to 3, x plus 1. So x is not a factor because it's not involved in any multiplication. Right, 2 more. Just multiplying here. I've been asked to express these as a single fraction in its simplest form. When we're dealing with more complicated fractions like this, it's often a good idea to look and see if anything will factorise, in particular the algebraic bits. So I'm looking at this bit here. 2x plus 8. These have got a common factor of 2. So I'm going to rewrite the whole calculation I'm going to factorise this bit. So 2 lots of x plus 4 times x plus 4, and I'm going to write that in a bracket, over 14. Now, looking carefully, I can see I've got this x plus 4 and this x plus 4 on the top and the bottom. So they can be cancelled out. I can divide the top by x plus 4 to reduce that factor to 1, and the bottom to reduce that to 1 as well. Some of you will have spotted in the original question that this is just 2 lots of this, but for a lot of folks it's often useful to just factorise it to help you spot these common factors. Now, while the algebra is important, we should also be looking at the numbers as well. The 7 and the 14 have both got a common factor of 7, so dividing both of these by 7 will give me a 1 on the top and a 2 on the bottom. And that's all my simplifying done. Remember, this 2 and 2, they won't cancel out because they're both on the bottom of my fractions. So I can go ahead and do my multiplying. On the top, I'm left with 1 times 1 to give me 1. On the bottom, I've got 2 times 1 times 2 is 4. So I've got that written as a single fraction in its simplest form. Next one, still multiplication, so I don't need to worry about flipping this fraction here, but looking at this, that can be simplified. Again, look at this, that plus 8 and the x's. This is leading me to believe that this is going to be involved in cancelling down. So I think these two terms are going to cancel down somehow. X plus 8, that won't factorise, but I'm just going to write it in a bracket. 15, 10, and now I've got this thing here. Well, there's x's in both of them, so I can take out an x term. However, I need to think carefully here. If I take out a single x, I'll be left with x squared and 8x. So I can actually take out x squared. X squared times x squared times 8. Now I can look and do my simplifying. So again, the brackets are really highlighting the fact that x plus 8 is a factor on the top and bottom. So I can divide the top and bottom by x plus 8, and that will reduce those factors down to 1. The x squared on the bottom, well, there is absolutely no x's on the top, so this guy is going to stay the same. But the numbers, 10 and 5, can reduce them down by dividing by 5. 5 goes into 10 twice, 5 goes into 15 3 times. I can now do my multiplying. I'm left with 1 times 2 on the top over 3 times 1 times x squared on the bottom. So I've written that as a single fraction in its simplest form. Again, just studying the answer, you can see nothing on the top and bottom will cancel out. I've got some division here on this page. The first thing you should do whenever you've got any fractional division is don't bother worrying about the factorising, don't worry about looking for things that will cancel out. It's just keep that first one the same and multiply by the reciprocal. This question, I've put this in to deliberately show you something. You might be tempted to cancel out the x plus 6 and the x plus 6 in these two fractions. However, when we change it to a multiplication, we can see the x plus 6's are actually both on the denominator. The x's here and the x squared, they're not going to cancel out because when I rewrite it as a multiplication, I can see they're both on the top. So never do any cancelling when you've got a division. Change it into this multiplication first. So multiplying the tops is going to give me x cubed. On the bottom, I've got x plus 6 times x plus 6. So I can write that bracket twice, or I can put a little square symbol down. So a nice straightforward one there, but be careful not to fall into the trap of cancelling things out when you shouldn't. Right, final one here, and it's belter. We've got a division, so the first thing we're going to do is not worry about how scary it looks. We're going to keep the first term the same, and we are going to, instead of divide, we're going to multiply by the reciprocal. So the second fraction gets flipped. Now at National 5, what I've done here earns you a mark, okay? I need to identify common factors, and to do that I need to factorise. The only thing that makes this more complicated than the ones before is the amount of factorising involved. It doesn't matter the order you factorise these in. I'm going to start with the easier ones to begin with. The easier one is probably the one on the top right here. X squared plus 8x plus 15. I've got a trinomial, which if it factorises should go into two brackets. I need to pick two numbers that multiply to give me this positive 15 and add together to give me plus 8. So that's going to give me plus 3 plus 5. The next level of difficulty is probably this here. We've got x squared minus 9. So as we saw in the simplifying video, this is the difference of two squares. So you either recognise it's the difference of two squares, or you factorise it by going, I need two numbers that multiply to give me negative 9 and add to give me the 0x in the middle. So that needs to be plus 3 and minus 3. Next in terms of difficulty is this. This one down here on the bottom right is still difference of two squares. And this is the ones where it's useful to just recognise it. I've got 2x times itself, and I've got 5 times itself. So I've got 2x plus 5 times 2x minus 5. Now, this one, you can factorise it using the split the middle method, the method I'm going to use for this top left one. Top left one's more difficult. Now, rather than doing all the steps for this and rewriting all of this over and over again, I'm just taking a little bit of space at the side of my page and I'm just going to factorise it over here. So I have got 6x squared minus 13x minus 5. I'm going to multiply the 6 by the negative 5 to get negative 30. And I need to find two factors that will multiply to give me negative 30 and add up to give me negative 13. Now be careful, you might be tempted to go, well, negative 10, negative 3. That'll add together to give me negative 13. But these two terms will multiply to give you positive 30. So that's no good. Negative 15, positive 2. They will add to give me negative 13, and they will multiply to give me that. Remember, if you're struggling to pick your factor pair, start at the beginning, 1 and 30, and just list them out in order. So my 6x squared doesn't change, my minus 5 doesn't change, and I split that negative 13 into negative 15x plus 2x. I factorise the first pair. They've got a common factor of 3x, 2x minus 5. There's no common factor there, so what I'm going to do is I'm just going to take out a 1, and it's 1 times 2x minus 5. So I've got this bracket appearing twice, so it's a common factor for the first and second bit. 2x minus 5 was multiplied by 3x, and then it was multiplied by 1. So this thing up the top left here will factorise 2. 2x minus 5, 3x plus 1. Remember, this method here could be used for this. You'd be looking for factors of negative 100 that add up to give you 0. And this method will help you factorise to this. Right, every single bit has been factorised, so now I can start looking for things that cancel down. Be organised. I'm just going to start with the top left and work my way along. 2x minus 5. I've got a 2x minus 5 on the bottom. So dividing by 2x minus 5 reduces those down to 1. A 3x plus 1. Nope, none of those on the bottom are 3x plus 1. Next one on top, I've got an x plus 3. Well, I've got an x plus 3 on the bottom. So they will reduce down to 1 if I divide the top and bottom by x plus 3. X plus 5. That's 2x plus 5, so it's not the same. So no more cancelling down can be done. So I have got 1 times 1, this bracket times this bracket. 3x plus 1, x plus 5. On the bottom, again 1 times 1, this bracket times this bracket. X minus 3, 2x plus 1. And that has been written as a single fraction in its simplest form. So, to be able to do this, you need to remember a few things. You need to remember division. We change that to multiply by the reciprocal. I hope I've spelt that correctly. You need to factorise. Then you need to cancel your common factors on the top and bottom, on the numerator and denominator. Only once you've done that, then you multiply together. Okay, you do that, you'll get these right every time.